Okay, so lengths of sides. We're using trig to calculate lengths of sides. So first off, thing to remember the whatever it is, Sohcahtoa, right? So what that means is you look at a triangle, you find the right angle, because all we're doing is right angle triangles, right? From that you name the hypotenuse, right? Or you indicate which side is the hypotenuse. And then you look at what information you have. Now if we're going to find the length of a side, then we're going to need the angle, which is, we're going to need an angle in that triangle, right? And then we can figure out, okay, in relation to this angle, we know the hypotenuse, or we know opposite, we know adjacent, which three, which two. And if we know opposite and hypotenuse, we're going to use sine. If we know adjacent hypotenuse, we use cos. We know opposite adjacent, we use tan. Okay. So here is a right angle triangle, and here is the right angle. And we'll call this triangle ABC. And we will say that there is a 30-degree angle down here, that there is a 10-centimeter side here, and we'll try and label this correctly. We will use trig to calculate side B and side C. Okay. So what we're going to say is, all right, this is the angle I know. I also know that angle. What's this angle? 60, right? But we're just going to stick with what we know. Okay, this is the angle I know. In relation to that, this side is? Really, in relation to this angle, that's opposite. Come on. What's this side? And what's this side? Okay, so if I want to find little c, then I'm dealing with opposite and adjacent and the 30 degrees. Which ratio relates opposite and adjacent? Tangent. Okay, so we would go tan of angle C is opposite over adjacent. The tan of 30 degrees is equal to little c over 10. So little c is 10 times tan 30. What mode does your calculator need to be in? Degrees, right. And you always got to make sure you write the degree symbol, right? Like if it's degree. So what is 10, tan 30, and let's round to the nearest 10th. 5.8 what? Centimeters, right? So always state the units with it, right? Whatever it is, kilometers per hour, centimeters, miles. Okay, let's do little b. So in relation to little b, remember there are three quantities involved in everything, right? With sine, it's an angle, the opposite and the hypotenuse. With cos, it's an angle. One of them is always an angle, and then there's two sides. So we're going to stick with this angle. We've got this side, which is adjacent, and this side, which is, so the trig ratio we use is? Cosine. Okay, so we go cos of angle C is equal to, now I guess we could write this out in the form, right? It's like C over, A over B, right? Adjacent over hypotenuse. Cos, let's fill it in, the cosine of 30 degrees is 10 over B. Now how do we rearrange this to get B, right? We want to write B equals something and then calculate it. So what's the proper rearrangement of this? 10 divided by cos 30. In essence, what it becomes simply you're switching places here, right? You can think of it, what we're really doing is we're going to multiply both sides by b, get cos 30 times b equals 10. I mean, I'll show you this, but we'll never do this. So you could say, all right, let's multiply both sides by b, whoops, giving me cos 30 times b is equal to 10, and then let's divide both sides by cos 30, and we'll get b. So what's b? Sorry, how much? 11.5? Sorry? Okay. Does it make sense? Is it longer than either of the other two sides? Should be the longest side, right? So 11.5 is bigger number than 8 and 10, so from that point of view, it makes, you know, it at least fits. Okay? If you, yeah, it could be wrong.
Wait, shouldn't the two legs added together be longer than the hypotenuse?
How about if you sum the squares of the two legs and see if it's equal to the square of this? And why would the two legs added together were bigger than the hypotenuse, you couldn't make a triangle. Wouldn't fit in there, right? And anyways, if you want to object, you can say, when I put this into my calculator, 10 divided by cos 30 was really this. Otherwise, you shouldn't be raising objections. So if you haven't worked it out, don't object to it. All right. So, easy way. When you are solving for the quantity that is in the denominator, you just interchange these, right? What you're doing really is you're multiplying through by it, and then you're dividing. But the net effect is just flip them around, right? When you're solving for a quantity here, life is easy, right? You're just multiplying both sides by 10. Okay? So either way, it's a pretty quick switch and flip, and you know, things work quite nicely. A lot of times we'll use the tangent ratio to solve for indirect measurement, right? Things that you can't measure directly, like the height of the flagpole up in front of the school. Right. I mean, well, you could, but I think they're going to frown upon you climbing up the flagpole with like a, you know, measuring tape or something, and then dropping it down to the bottom where your friend's waiting. So, hey, it's this tall, right? So, you know, but you might be able to get a surveying type instrument and measure an angle to the top of the flagpole. So, like, you know, here's the flagpole here, and you're down on the ground, and you can measure this distance. We're okay with you, you know. We're saying, okay, that's 10 meters, right? You're okay measuring distances along the ground. And then you're looking up at an angle of, let's figure this out, if I'm about 10 meters from the flagpole. Let's probably say about 8 degrees maybe. And I want to figure out this height here, right? Okay, so in relation to 8 degrees, what's the name of this side? Okay, this is opposite, and this side is? And which ratio do we use? All right, so let's skip to the chase, right? We'll just write the tan of 8 degrees is opposite, which is h over 10. So h is equal to 10 times the tan of 8 degrees, which is 1.4. Well, okay, so that's kind of a messed up. If you're 10 meters back, I guess you're looking up at more than an 8-degree angle, right? All right, so let's adjust this a little bit and think about it. Let's make this 68, right? That doesn't change much there. And then we put a 6 there, and we put a 6 there. Okay, what's that equal to? 24.7. That's way too high, but sounds better anyway. 24.8, I hear? Wait, which is it? Okay. So this brings up rounding, right? You gotta watch your rounding. In pure 30, not pure 30, in 30-1, whatever variety of 30-1 you take, you know, a higher level, standard level, just regular 30-1, you're writing a diploma exam, which consists of what? No, how many multiple choice? She doesn't know. You guys are always asked whatever you test. What's on this test? How long is it? 44 inches, the same as every other.
Most of it, like 60% is going to be trig.
There are, oh, okay. There are 28 in a year, most of you next year. There are 28 multiple choice and 12 numerical response. Okay? Now, that's it. 40 questions, each one worth 1.25% of your mark in 30-1. But, you know, 12 numerical response means you do not want to be making rounding errors, okay? Some of them will just be straight work it out, right? It's like, you know, to the nearest tenth, blah, blah. Some of them are, you know, the answer is expressed as a root b. The value of a plus b is, okay? So you need to read the question, right? Especially with numerical response. You can get away maybe with multiple choice. You don't read it so carefully. The numbers are never that close that, yeah, I'm off by a little. Well, this is probably the answer because there's nothing close to that, right? Numerical response, there is no off by a little. Off by a little is called wrong. Okay? So you can't. You're off by a tenth. You round it to 0.6 when it's 0.7. That's wrong. All right, let's do a sine. We haven't done a sine one yet. So let's do a sine. We've done angles. Let's do a length. Go to a new page. Okay, so in relation to the 27 degrees, what's the name of h? Opposite. What's the name of 15? Hypotenuse. Which ratio relates opposite and hypotenuse? So we're going to say the sine of 27 degrees is h over 15, which means h is 15 times sine 27, which is 6.8. What units? No units. Right? There's no units in the question, so then it's just 6.8. Right? It's just a number. Let's do one other. Yeah, I had to throw something different in there. Let's go. Okay, in relation to the 17.8 degrees, 12 is, and x is hypotenuse, okay? So we set it up right. Sine 17.8 degrees is opposite over hypotenuse. We know the rearrangement now, right? It's going to be 12 divided by the sine of 17.8 degrees. Is it longer than 12 or shorter than 12?
Longer.
Should be longer, right? It's hypotenuse, it has to be the longest side. And what do we get? 39.3. I don't know. You said round. You have 39.23? 254, which is 39.3. You have 39.254. Okay, let's go back to rounding school.
No, please.
Okay, look, the one thing you don't do is you don't cascade rounding, as in you don't start out here and just start rounding your way in, which in this one won't make any difference because it'll still be 39.3, so regardless, that's 39.3. But you don't cascade your rounding, so in other words, if I have like 39.4999 and I want that rounded to one decimal, what is it? 39.5. Bad example if I wanted that to. Okay, if I had 34 point, I don't want to select you. I don't want to select you. I want to raise you. Okay, here. 4499. I want to round that to one decimal place. 39.4. Okay, so by cascading rounding, I mean, you don't start here and say, oh, well, that rounds to 39.45, and 39.45 rounds to 39.5. Okay, we don't do that. You look at the place. This is the place. You look to the right, right? If it's 5 or higher, you round up. If it's 4 or lower, you leave it. Okay, and you don't look here and say, but wait, that's if I want 2 decimals, that's 39.45. Right, but if I want 1 decimal, it's 39.4. Okay, so don't cascade your rounding, and really, lengths, how much easier could it get? Not much. There is some stuff.